realize we had more people tonight than we had last night. So yeah, question 7, I think, is next in our queue. All right, so who wants to give us the numbers? Because my numbers, as you can see, didn't quite come out quite right. So how many moles of propane do we have in this reaction for someone?
0.229.
So yeah, yep, we're good. We're good. We got John 0.165 moles of propane, right? Propane reacts with oxygen to produce this, given the following balance equation, blah, blah, blah. How many moles of CO2? So here, right, we know for every 1 mole of propane, we're going to make 3 moles of CO2. So we're just going to use that mole ratio to say, okay, 1 mole of propane in, I'm going to get 3 moles of CO2 out. So that cancels out, right? Everyone's numbers will be slightly different, but the steps would be the same, right? So 0.165 times 3, and I get about 0.495 moles of CO2 in that reaction. So mole to mole, just using the mole ratio. All right, I think we've got question 11, question 12 up next. Yeah. So question 8 is going to be very similar. I mean, bomb calorimetry is definitely more of a closed system. Yeah. Compared to coffee cup calorimetry, right? So question 9, question 8, just kidding. Right now, this is just one step farther. We've got 22 grams of water. You know, how many, based on the mass of water, how many grams of oxygen were consumed? So now we're going the full step. We're going the full step, right, in this calculation. So mass to moles to moles to mass. Yeah, Arthur, you won't have a question that's quite that hard on the exam. So we've got 22 grams of water. I can't do anything, right? We're going to map this out. I'm going to go from grams of water to moles of water using the molar mass. I'm going to use the mole ratio, right, to convert moles of water into moles of oxygen. And then, again, I'm going to use the molar mass of oxygen to find grams of oxygen. So, all right, I know that water is 16, 17, 18.2 grams per 1 mole. So 22 divided by 18.02, I get 1.22 moles of water. Next, I'm going to use the mole ratio. Right, the mole ratio tells me for every 4 moles of water, I need 5 moles of oxygen. So 5 moles of oxygen on top, 4 moles of water on the bottom. Water cancels out, and 5 over 4, right, I get 1.52 moles of oxygen. The last step, right, to go from moles of oxygen to grams of oxygen, we need the molar mass. So 1 mole of oxygen is 32 grams per mole, right? So multiply by 32, and I get approximately 48.8 grams of oxygen. My number comes up as 2 significant figures, but I'm thinking it's probably should be like 3 significant figures, depending on what numbers you're given. So just be careful of that. So for me, I would say like 49 grams because I just used 22 grams, which has two significant figures. All right, I think someone wanted question 9. Yeah, Anthony, the same reason we used 70.9 when dealing with chlorine, right? Oxygen is O2, one oxygen is 16, so 2 oxygens would be 32. That's the molar mass of diatomic oxygen. Yeah, question 9 is a good one. I think just we don't even have to do math to figure out question 9, right? It's the Haber process where nitrogen is blue, hydrogen is white, and what molecule is limiting reagent, what molecule is in excess. So for this reaction, right, for every 1 nitrogen, we need 3 hydrogens. So literally we can go in and say, okay, here's 1 nitrogen and 3 hydrogen. Here's 1 nitrogen and 3 hydrogen. Here's 1 nitrogen and 3 hydrogen. All the hydrogens consumed. So all the hydrogen is consumed. So that would be our limiting reagent because the hydrogen is gone. It's all consumed. It stops the reaction. And then the one thing we have left is nitrogen. So that would be the excess reagent because if I had more hydrogen, I could use that nitrogen. And then how many excess molecules remain? You know, basically 1 molecule of nitrogen is in excess in this reaction for question 9. Yep. Yeah, we're working that direction. I think someone wanted question 10 first. Yeah. Someone other than just Lauren wanted question 10. Yeah, question 10 is there's a lot going on in question 10. Yeah, we're working that way. I'm on 10 right now as we speak. So we've got 2 things. I've got 48 grams. So Emily asked a good question. It's a direct message, but I'll share it with everyone. I would say the practice exam is harder than the real exam just because it's open notes, open books. Like there are some, like question 10, I wouldn't make a full question like question 10 on the real exam, but certainly parts of question 10 would be a question. Like finding limiting reagent would be a question, or finding the mass of a product based on limiting reagent would be a question. It wouldn't be all 4 parts of that question. Question 16 is definitely, I wouldn't put a question like 16 on the exam. So for question 10, right, I've got 48 grams of aluminum. I've got 225 grams of iron 3 oxide. I can't compare them as grams. I need to get them into moles. So 1 mole of aluminum is 26.98 grams. And then 1 mole of iron 3 oxide is 159.69 grams. That's the molar mass of those. So I think this is 1.77. Let me check. 48 divided by 26.98. Yeah, 1.779 moles of aluminum. Do the same thing for the iron 3 oxide, 225 grams divided by 159.69, and I get 1.409 moles of iron 3 oxide. I still can't compare them because they don't have the same units, right? So rather than find moles of a product, I'm going to find limiting reagent, I want to convert both of them to the same number of moles because they react, right, with a different whole number ratio. So the next thing I'm going to do is convert them into moles of iron 3 oxide. Yeah, so good question, right? How do they not have the same unit if they're both in moles? They're both in moles, but they're both in different moles, right? One is moles of aluminum, one is moles of iron 3 oxide. So they're only partially the same, right? I still need to convert them into the same moles of the same reagent. So I'm going to convert them both into iron 3 oxide. So I go to the reaction, 2 moles of aluminum require 1 mole of aluminum iron 3 oxide. So, all right, for every 2 moles of aluminum, I need 1 mole of iron 3 oxide. And now they're going to be in the same units. So 1.779 divided by 2, right? I get 0.8895 moles of iron 3 oxide. This is important because now I found my limiting reagent. To consume all of the aluminum, I need 0.8895 moles of iron 3 oxide. I actually have 1.4 in the reaction. So that tells me the excess and limiting reagent. The excess reagent is the iron 3 oxide because I have more than I need. The limiting reagent is going to be the aluminum because when all of that aluminum reacts, I'll have only used 0.8895 moles of the iron 3 oxide. So yeah, Josephine asked, how did I know to do that with this and not something else, right? We could have done it for either one, right? We could have done it for the aluminum. We could have converted iron 3 oxide to aluminum. We would have still found that, oh, I need more aluminum than I have. I still would have found the limiting reagent. So we just have to pick one and convert them both to that one unit. And then let me just catch up with the questions here. It doesn't matter which one I choose, right, Ella? I can choose either, but I want to convert them both to the same one. And yeah, Rochelle asked the same question, right? I want them both in the same units. Limiting and excess was module 4, Anthony. Yeah, so we're still there. So now I want to find excess. Yeah, I'm headed that direction, Alexa. Exactly. Yeah, Arthur. We could convert them to the products as well. So I've got 1.4 more 1.409 moles of iron 3 oxide, and this is how much I have. I use 0.8895 moles. That's how much we use. So to find excess, right, we're just going to subtract those two. And 1.409 minus 0.8895, right, we've got 0.5195 moles of iron 3 oxide excess. So to answer part D to this, right, to find the mass that's left over, well, I know for every 1 mole of iron 3 oxide, I need to have 159.69 grams. So 159.69, right, we're going to have like 83 grams of excess iron 3 oxide. All right, we're all set with question 10. Oh yeah, part A. Grams of aluminum oxide that can be made, well, 0.8895 moles of aluminum or iron 3 oxide. That's how much of this we're going to use. So yeah, let's find out how much aluminum oxide that's going to make, right? Well, we know for every 1 mole of iron 3 oxide, I'm going to make 1 mole of aluminum oxide. we would get the same answer if I use the moles of aluminum. We get the same answer. So, okay, I'm going to make 0.8895 moles of aluminum oxide. And to find the grams of aluminum oxide, right, 1 mole, molar mass of aluminum oxide is 101.96. So multiply by 101.96, 0.8895 times 101.96. And yeah, I get like 90.7 grams of aluminum oxide that we'll make in that reaction for part A.